we have Max and Philip. Just to make you both as a co-host, so you will be able to share your screens, I'm assuming. So yeah. So next, let's welcome Max and Philip. Both of them are actually senior developers of a unique network that will share with you writing and invoking custom Solidity contracts in the unique Substrate SDK. Easy peasy. Okay, please go ahead, Philip.
All right, thanks you. Does everyone hear me? I suppose the microphone is working. So, well, welcome to this challenge. I'll add the introduction. Matt will continue on with it of actually tackle the challenge and what tools we'll be using. But there are some things you need to know regarding the unique network to actually understand why we phrased it the way we did. Why is this the title of the challenge and what the challenge actually is? So first of all, unique network is a parachain on the Polkadot system. We have three chains, the production chain, which is unique, quartz, which is on the production chain. The unique chain is on the Polkadot. There is a quartz chain, which is on the Kusama, and we also have Opal, which is a development network. Now, you will be probably developing on the Opal for the simplest reason that the coins you can use for transactions are valueless, which means there is a faucet which can give you any amount of tokens you need to kind of develop and work. So essentially, Opal is the development. Making anything into shifting over to production is really simple. You just change the endpoint and things just work. There is one more aspect of unique networks development. This, how would I say, the bundle of networks. It is the capability that is provided through the Ethereum virtual machine. Among those three chains, we also have an Ethereum virtual machine. We're substrate first, but we do have a fully functioning EVM. And the thing that is very important that I need you to remember from the very start is that in unique network, the EVM addresses used in EVM one-on-one with substrate addresses, which makes interoperability of the EVM with the substrate basis very, very simple because of this one-on-one mapping. And this actually provides you the ability to use both MetaMask and Polkadot wallets in the same kind of address space. You will need to use a certain function called cost address, which Max will stress very strongly in terms of the use, but that's not the operation. I just have to clarify one more thing before I pass it off to Mac, and that is the question. So, unique network being an optimized chain for the really features for NFTs. So everything like nesting, dynamic NFTs, composable NFTs, refungible NFTs, all these are covered by the features, which are precompiled contracts, which actually makes it possible to use it without writing any contracts, just by making calls through the SDK to the core functions that are in the pallet, contained in the pallet themselves. So it enormously simplifies the process of creating and managing very complex NFTs. And the question that arises then is, so what do you need the EVM for? Well, the EVM then is actually provides a capability of writing contracts to extend the functionality of what you're building. And this might be decentralized minting or some super functionality through, I don't know, complex royalty schemes or whatever you can imagine. But Max is going to show you how actually you connect these to the SDK and the EVM contract, and the Solidity contract that you write within the EVM, how these addresses reflect. And from that point on, your challenges with this and the bounty we'll be providing with is the most interesting kind of interaction between the contracts that is written on the EVM side and the SDK development in JavaScript. From the on, I give it to you, Max. Please show the magic.
Hi, everyone. Can you hear me? Can you see my screen?
Yes, perfect.
Yeah. Screen visible.
Yeah, cool. So, yeah, right. Hey, everyone. So we don't have too much time, so let me jump straight to the demo. For this demo, I will explain how to use unique network EVM precompiles to create native for unique network collections and NFTs. You will understand what are the benefits of using this approach. And yeah, also we provide you a set of tools to rapidly start your development. For the demo, I will show you a very simple Web3 game with slightly silly rules, but this game is very close to the one you need to develop through this hackathon. In this game, your contract manages a collection, and in this collection, you can read some creature, which is pseudo-randomly selected from this blue one and this red one. And after that, these creatures may fight against each other. And yeah, if this creature loses the battle, it became slightly exhausted, like this one. Also, your creature can gain some experience, and at some point, if it gained enough experience, it can be evolved. So basically, this creature evolves to this one. And everything I will show is happening completely on chain. So no off-chain services, no backends, and no privilege keys needed to create such experience. Also, here is how this game will look like. So here's your squad. You can breed new creature. You can select some and put it on the arena and fight against the other creature, gain some new experience, and evolve it. As I said, we will provide this boilerplate code. It will help you to concentrate on the application logic, not fighting with boilerplate, setting packages, and connecting to the accounts. So in this boilerplate, you have an access to the Polkadot wallets. Here's the list. Also, we provide an access to the Ethereum wallets through the Wallet Connect. Okay, so here is the first thing you need to know. Take a look to the README. Basically, this is a text version of today's workshop. It's quite comprehensive and explains everything in the details and provides every single link you need. Yeah. So now about this project, it consists of two main parts. The main part at the root is React project, and here is in the contract directory, you may find very simple Hardhat project. Let me show you. Here is only one contract here. We have a closer look a bit later. Let me show you a config for this project. A couple of things you need to know. The available versions for the Solidity cannot be higher than this one, 24. We do not support high version for now. Also, you have to use via intermediate representation compilation pipeline. And we also have predefined network here for the opal, which is testnet. We already deployed contract for this demo, but if you want to deploy your own contract, just provide your private keys and run scripts to run a script to deploy your own contract. Here is the script, and you will find deployment script in the package JSON. So everything is ready to be hacked. So also you will find in the README a link to the Faucet bot. Let me find it. Faucet. Here is a Telegram Faucet bot. Here you can obtain OPL tokens for free. Yeah. Okay. Now, before we jump to the contract, let me show you how React project looks. Here is app.tsx file, and here is a couple of providers. Wallet Connect provider for the Ethereum wallets. SDK provider is for Substrate wallets and for the SDK. And the account context provider is for the selected account. So very simple. For now, it's main, and that's it. So it's very simple. For the pages, here's only one page, reading page. So let's have a look. Reading page 6. There are a lot of comments here. You will easily understand what's going on here. But let me quickly walk you through this, through the main variables. So first, here's a couple of constants here. This is all these constants related to the already deployed, just hard-coded contract address, collection ID, and this one is for the application logic. Here is a deployed collection, 3997. Yeah, this is collection. This collection we will work with. Also, a couple of useful hooks. First one is use chain and scan. This hook provides an access to the unique network SDK, and this SDK consists of two parts. First is chain and scan. Chain is for blockchain interaction, sending transactions, retrieving data from the blockchain, and scan is for the retrieving data from the unique network indexer. And also important hook for the selected accounts. We will use it often in the project, but basically it's very simple. It provides an access to the selected address. Okay, everything else is related to the application logic and to the contract. So let's jump to the contract and let's have a look how it looks like. Okay, here's very simple, basically reading contract. Couple of things to notice. So unique network provides a set of precompiles which allows you to mint collections and NFTs, which would be native for unique. So you don't need to deploy ERC-721 contracts in unique network. You can, but it doesn't make a lot of sense. For us, it is better approach to mint native collections and tokens because they will have more features like nesting, like refungibility and so on. But it can be slightly tricky part because it is not always easy to. It's not enough to just mint NFTs. You also have to stick special metadata format to make these NFTs compatible with existing interfaces like wallets or scans. So for simplifying experience, we provide this package, which is unique NFT contracts. Here is the repo for this package. I also recommend to walk through this repo. Let me quickly explain how it works. It provides basically not so much abstract contracts. One contract is for collection minting. It provides create collection function. So that's it. It's very easy to create collection. Just call this function and you're good to go. Token minter abstract contract provides functions to create for creating tokens. Token manager contract provides functions to set token images and token attributes, traits, also retrieve images and trait values. And address validator, it's slightly difficult to explain without examples. So let's return back to the contract and let's have a look how it works. So in the constructor, we create a collection using min collection from the collection minter contract. We provide some stats, some info for this collection, like name, its description, symbol, and this one is for collection cover. So that is how it will look like. So this is our collection. It has its symbol, some description, and yeah, that's it. So this code relates to the logic of application. I will not explain it. One thing to notice, min collection is payable function. You need to provide value for collection minting. So do not forget to put 2 OPL tokens for this collection. You can actually implement your own logic. You can pre-fund your contracts, for example, and you can make a gasless experience for your users if you want. But yeah, basically you still need to provide these tokens to the function to mint a collection. Okay. Next very important function is breed. This function explains several concepts. First, here is a cross address which we pass to this function. So basically what a cross address is. As Philip mentioned, we are substrate-first blockchain, so we have support for both Ethereum and Substrate interfaces. And Substrate accounts can interact with EVM contracts, but here is a problem. EVM do not understand Substrate format, Substrate accounts format. So to make it possible for Substrate accounts call contracts, we have a concept of account mirroring. So every Substrate account has its own Ethereum mirror. And actually, when Substrate account calls this breed function, the message sender for this function would be its mirror. Okay, it works fine, but the problem is if the message sender is Ethereum address, how can we mint this NFT for the Substrate account? Because the owner will be Ethereum address in this situation, right? So for this purpose, we provide cross-address struct. Let me show you how it looks. Yeah, this is cross address. It is very simple struct which contains two properties. If property is for the Ethereum addresses. So if the contract origin is Ethereum address, you need to provide if property with its address, and you need to set sub property as 0 for the substrate. And if the origin of the transaction call is substrate account, then you set for if property address 0, and you put substrate public key for the sub property. It may sound slightly complicated, but actually it is very easy. I will show you how it works later when we return to the React project. The second important part you may want to use, because you may want to check if this address is really message sender. So you may want to use these modifiers which provides by this address validator contract. This modifiers checks if this cross address is really message sender. In some cases, you probably won't check it, and you may want to allow everyone to mint for every random address. But for this example, we definitely want to owner being the message sender. Okay, this logic is just pseudo-randomly selects creature. So the next important part is this one. We create a set of attributes. Let me show you how it will look like in the scan. So this is our creature. It has 4 traits, and yeah, these traits we provided here: experience, victories, defeats, and generation. And after that, we just call create token, and that's it. We mint a new token. Let me run this. I can call this function from this substrate. This is Polkadot wallet. I will not wait, but let me return it to the project. It will take some time. Yeah, okay. The last thing I need to explain is how token manager contract works. This contract is for attribute mutation. And here is a couple of functions that implements the functions from this token manager contract. For example, this evolve function responsible for evolving NFT when it gains enough experience, which is set to 150 here. Yeah, and if it's enough, it sets different trait for the generation. It increments its generation, and it also changed the token image. So I will not explain the other functions because basically they do not contribute anything to understanding of these contracts. So just have a look. There are a lot of comments here, so you will understand it easily. Okay, now let me jump back to the front-end project. And maybe, yeah, I just created one new creature here. So yeah, this works. Now, let me explain how you can invoke these contracts from using Substrate and both Substrate and Ethereum addresses. Here is send transaction function. You may find this is a helper function. This function checks if the selected account, which is provided here at the account context, if this selected account is Polkadot wallet, it uses EVM. It uses unique SDK, and it sends transaction this way. Okay, and if the signer is Ethereum wallet, like MetaMask, for example, it uses others as usual. So next we use this send transaction function. Very easy. Here, for example, for the breeding, this handle function for breeding. Here's we invoke this function to create a new token. Okay. One more concept to explain. It's probably how to retrieve data. There are two ways you may use. First is using unique SDK. For example, this function for fetching Gladiator. Gladiator is the token that currently on the arena. Let me put some token there. So this function uses SDK, and it's also very simple. You need to provide function, arguments, contract API, and contract address, and that's it. That's how you can invoke data using SDK. Okay, and the second option you may want to use is scan for example, if you want to get a lot of data, for example, all the user tokens, it would be much easier, and it would be probably the only way you can do this is using scan. So it's also very easy. I don't think I need to explain how this code works. Just have a look, and that's it.
There's the promise, Max. So there's the promise of the easy peasy. We said it would be easy peasy. There you go. It's just these very simple calls, and magic happens.
Yeah, right. So basically, that's it. Just walk through these code examples. The only link you need is unique React template. We will provide this link. So can we drop this link somehow, Philip?
So I think we'll get contacts from the organizers to connect with the developers, and we'll be able to provide that. So don't worry, we'll make sure you have access to this one way or another.
Yeah. Okay. So that's it for me.
And before you close, we have a few more minutes. I don't know if we're going to break the minute, but I just wanted to make some very kind of important notes on this. First of all, let's just recap what we showed here. We used essentially three technologies. We use React to a template to build some kind of an interface. That's not the point of this discussion. React is React. It's just a simple framework through which you enact interaction. However, behind the whole concept of interacting with the blockchain is the idea that you will be using the SDK to do easy stuff. Like, as we said here, invoke the scanner, get the data, read the data. However, the SDK also provides a framework through which you can make calls and implement the contracts that you write on the EVM. So this was the presentation in the sense that those are the elements that are displayed in this example. Now, this example is a game, and we're not saying go out and build games, like copy this and make a different game. This whole presentation is created so that it's actually very, very modular. It was created so you can pick and choose elements that you need to create what you need to do. For example, There is a part that handles the wallet interaction. Just pluck it out and put it in your project. There is a part that makes access, that creates and mints the NFTs. Pluck it out and put it in your project. Your task will be to play around with this concept and implement some kind of a, well, it doesn't have to be a game. It can be a game, of course, which uses an interaction of some contracts, that is distributed computing applied to and decentralized computing applied to some kind of function, and interacting it with the SDK to build something interesting. So make it wow. That's all I can say. Play around with it. And one more point that is very important is the reason why our EVM is not exactly like the Ethereum, the approach of using the EVM is not exactly like programming on Ethereum, is that we keep all our data related to the NFTs on chain, which means they're not contract driven, contract contained data. It's data contained on the blockchain, and you use the contracts only to access the data, which allows you to easily mutate any parameter that you declare as mutable in the NFT. I hope that makes sense. With that, we've kind of completed the workshop, and I hope everybody had fun.
Thank you, Philip, for the recap. Thank you, Max, as well.